Hey guys, so today we're going to finish our notes on topic 17. We're going to continue talking about probability, but more specifically, we're going to talk about simulations. So a simulation is a way to model random events. And we do this so that the simulated outcomes closely match real-world outcomes. By observing simulated outcomes, researchers can gain insight into the real world. And it says use any known probability to assign numbers to represent each outcome. So right here we have probability. All right. So for example, a quarterback completes 60% of his passes. So for our simulation, we would use the numbers 1 to 10. And since he's completing 60% of his passes, we would assign the numbers 1 through 6 to count as completed passes. This would be 6 out of 10, which we know is 0.6 if we divide, which is equal to 60%. So that represents our 60%. And then the incomplete passes, we could use the numbers 7 through 10. That is 4 numbers. So that would be 4 out of 10, which would be 0.4, which would equal 40%. So that would be a way we could run a simulation that would help us to model his 60% of completed passes. All right, so let's take a look at some practice and we can work through some practice problems together. All right, so this one says a grocery store finds that 30% of its customers bring their own bags. Which ways of assigning numbers to outcomes can you use to simulate the probability that a customer chosen at random brings his or her own bags? All right, so we're going to look at each of these and we're going to take a look at the probability. We're going to take a look at how we assign the numbers and what that looks like. So in this first example, we have own bags would be assigned to the numbers 1, 2, and 3. And then use other bags would be assigned to 4, 5, 6, 7, 8, 9, and 0. Okay, so first of all, we count and we look at how many total numbers we're using here. So 1 through 0 or 0 through 1, there are 10 numbers there. So using their own bag, that would be 3 out of 10. So we could write that as 3 over 10, which is equal to 0.3, which equals 30%, which matches what we were talking about. So we want to check this bottom part, the people that are using the other bags. So now if we look at that, we have 1, 2, 3, 4, 5, 6, 7 out of 10, which would be 0.7, which would be 70% who do not use their own bags, that would use other bags. So according to this, and according to how we have this set up, this would definitely match what we found up above in the problem, that 30% of customers bring their own bags. Now we want to check the other ones as well and see if there's any others that also match. So in this second one, it says use your own bags. That would be 1 to 33, and then other bags would be 34 to 100. So we're looking at a total of 100 numbers. So people using their own bags would be 1 to 33, so that would be 33 over 100, which if I change that to a decimal, I divide 33 by 100 and I get 0.33, which equals, 0.33, which would equal 33%. Okay. And then the other bags, 34 to 100, this would be 67 numbers, which would be 67 over 100, which would equal 0.67 or 67%. And again, this is a complete probability model. It adds up to 100, but it is not representing our 30% in this problem. So we want to look at example 3. This one says people use their own bags. That would be numbers 1 through 10, and other bags would be 11 through 30. So 1 through 10 would be 10 numbers. I'm just going to kind of bring this down here so I have more room. So that's going to be 10 out of 30. And if I divide that, I get 0.3 repeating. And then as a percent, that would be 33.3 repeating percent. And then if I look at these other ones, if I'm looking at 11 to 30, that is going to be 20 numbers out of our total 30. So 20 30ths, which then when I divide 20 by 30, I get 0.6 repeating, which would be 66.6 repeating percent. And again, we're looking for 30% of customers using their in bags. So only scenario 1 here would be our simulation, which one would actually simulate the probability. Okay, so let's take a look at another practice problem. It says of students in the middle school, 18 out of 25 went to the school dance. We want to focus on that 18 out of 25. All right. Which of these ways of assigning numbers to outcomes could you use to simulate whether someone attended the school dance? And we're going to check all that apply. So we are looking at 18 out of 25. What we're going to do is look at these different numbers here. And really, before I even do that, I want to calculate what 18 out of 25 is. So I'm going to come over here and I'm just going to figure out what that is. So 18 out of 25, I'm just going to divide 18 out of 25 equals 0.72, which equals 72%. So I want to look for that. So then looking at my simulations, I have this first option of using the numbers 1 to 100. Students that did not attend would be assigned numbers 1 through 28, and students that did attend would be assigned 29 through 100. So let's take a look at, I think I had that backwards. Sorry, students that did not attend would be assigned 1 through 28, and students that did attend would be 29 through 100. So I'm really going to focus on the ones that did attend because I want that to match my 72% here. So from 29 to 100, that is 72 numbers out of 100, which would be 0.72, which would be 72%. So this would be a correct simulation. Looking at the second one, it says use numbers 1 through 10. Students that did attend would be given the numbers 1 through 7. So we're looking now at the numbers 1 through 7. And students that did not attend would have the numbers 8 through 10. So we're going to look at 1 through 7. That means that is 7 numbers out of our 10 numbers, so 7 over 10, which if I divide would be 0.7, which would be 70%. So that would not match up to our 72, so we're not going to check that one off. Moving down to our third one, we have used numbers 1 through 50. Students that did attend were assigned numbers 1 through 36. Students that did not attend, we would assign 37 through 50. So again, we're looking at the numbers of the students who did attend. So we're looking at 1 through 36. That is 36 numbers out of 50, which when I divide, 36 divided by 50 gives me 0.72, which then when I multiply that by 100, I get 72%. So this also matches. So we could run that simulation as well. And then we want to check our last one as well. Use numbers 1 through 40. Students that did not attend would be 1 through 144, and students that did attend would be 145 to 200. So we're going to look at how many numbers, and actually this should say 1 through 200. I don't know why I had a typo there. Sorry about that. All right, so the numbers 1 through 200. So 1 through 44 did attend or did not attend, and 145 to 200 did. So that means from 145 to 200, that is 56 numbers out of my 200 total numbers. And then when I go ahead and divide that, I would get 0.28, which is 28%. That is actually not going to match up. We could actually reverse this simulation, because if we would have done the numbers 100 or 1 to 144 and said those are the students who did attend, then that would have actually given us the correct simulation, because we would have ended up with 72%. But with the way it's written, that's not going to work. So the way they're written, only these two that we checked off would provide a correct simulation, would be one that would match closely to our actual probability. Okay, I know simulations can be a little confusing, so if you need to go back and kind of watch this at the beginning again, or if you have any questions, please ask your teacher. Otherwise, you guys are going to do your own activity where you create your own simulation. So again, make sure you ask any questions if you're stuck or you don't understand.